Welcome everybody. Sorry for technical problems. I have a Linux and it's kind of backfired on me, so yeah. So welcome to talk, pain of growing up and moving to large scale. So first, let's meet. My name is Vladimir Dejanovic. I'm the founder and leader of Amsterdam Java user group, and as my day job, because I need to pay the bills, of course, I work as chapter lead at ING. For you who don't know, ING is the bank, and when it comes to the banks, we are the front runners in IT, and the goal for ING is also to become front runners in IT in old type of companies. So, what's going to talk today about? What's the agenda? First of all, I'll be talking about on what we concentrate, what actually motivates us, what make us get out of the bed and go to work, what rocks our boat, so to say. After this, I'll be talking about the growing up and all the pains that come with it, but also the benefits that come with this process. After that, I will spend some time talking about some deployment processes, and I'll try to go a little bit differently than it's usually done, in the fact that I will look at the good sides, but also the bad sides. And the bad sides are usually the ones that people don't talk about when they introduce something new. After this, I will spend a lot of time giving you a lot of tips from my own personal experience, from working in different type of companies, different type of procedures and ways of working, but also from other people and experience that I got from them. At the end, there will be some time for questions, so if you have any questions during the talk, please wait until the end and then ask them, or you can always find me after this talk here, or of course online. So, on what we concentrate? What's the thing that actually moves us, that motivates us, like I said, to get up out of the bed and go to work, except the pay, of course. Well, first of all, let's start with the question, like, what's the most interesting thing for you? When you actually start working on something, what is the first thing that catches your imagination and that actually catches you? Is it maybe the new features that you're going to add to your product and make them stand from the other products and make it unique? Or maybe it's some ideas that you want to implement, something new to develop, some integration with some other products. Or maybe you are really just techie and you want to develop, right? So you're most interested in actually developing the code, writing some crazy new algorithm which is going to be much better than anything else before. Or maybe you want to actually try some new framework or new language and solve your problems. But during this process, we also have one other thing that is very important, and then in the end, if you only develop the code and develop the product, it doesn't really matter, right? Because you need to ship it to your consumers. You need to somehow to deploy it, to send it to production. So when you actually start thinking about the deployment process, what your infrastructure is going to look like, how are you going actually to push your code to the production, to the end users? Well, if you're a real Boy Scout, you will start thinking from the start, right? As soon as you start thinking about developing something, you also start thinking, okay, how I can shape this to the clients? What infrastructure do I need? What are the processes? Or if you're on other part of the spectrum, then you'll probably start thinking at the end. And at this time, probably the budget is almost gone, the time is almost gone, you have it, and then you say, oh yeah, we need to ship this, right? Or maybe you're somewhere in between, right? Not completely at the start, but not also completely at the end. Well, the harsh truth is actually that it doesn't matter if you start thinking from the beginning or at the end or somewhere in between. Nothing actually guarantees you that this is going to be good. It can go bad in any single point of view. So if you start from the beginning, you can think, okay, like, yeah, I'm going to think about everything, make everything, and I know what's going to come, right? What the future is. And then somewhere along the process, you can find out actually that's the truth and the reality is much, much different. So it doesn't have to be the case, right? So you have to constantly revalidate your assumption. If you start thinking about this at the end, then the good thing is that, oh, you already have your product, you already know what your dependencies and things like that. But also, so in theory, you can maybe make it better, right? But also in practice, you can maybe find out that you made some assumptions along the way, which now are going to make your life hell. And again, also, if you're somewhere in between, again, it's going to go anyway. Like I said, deployment isn't the product. In the end, your users care about the product. They care about how good it is, how nice it is, how user-friendly it is. If your deployment process is terrible, the only people who are going to actually to suffer is you and your colleagues, right? Users will not notice it. Again, if you have like beautiful, shiny deployment process and everything is perfect and magically happening out of the box, right? Users don't care. If the product sucks, it doesn't matter, right? Unless, of course, you're making the deployment process. In this case, it should be shiny and magical. So, growing up. Well, I would say the growing up is a painful process, even for people, right? I still remember the days when I grew up, actually, and I was in the kindergarten, and somebody told me, no, you now need to go to school, right? You can't play all day, you can't eat candy all the time and watch cartoons. It was a painful process. And the worst part is it didn't end up there. You know, after the elementary school, there's high school, then there's faculty, then it's work, then it's paying bills, paying taxes, and all other things, right? So it continues to be painful. But again, the good side is now I can buy all the candy I want, and I can eat it before the lunch, and nobody can tell me differently, right? So there are also pluses. Well, it's similar thing also when we have our products, because usually it starts very simple. We start with the idea, we build something, we have some server and some database, and we put it there, and we have some process to actually send the data to the production. Maybe it's like some magical things, maybe it's just one script that we do it, or maybe it's a manual thing, who knows, but we figure it out. And usually at this stage, we don't usually have a lot of users, so we can, even if our process is not that good, we can live with them, because we can very simply deal with the downtime of few hours. Nobody will notice, right? If you have like 1 or 2 users, like you can do it while they sleep. But then, of course, if you're good and if you're lucky, your idea is very good, you have started getting more and more users, and then, oh yeah, the complexity goes up, because then you start ending up with something like this. You have multiple servers, multiple databases, then you need to add the load balancers and who knows what, you know, so it starts being complicated very fast. And in this case, you start actually feeling all the pain. You see if your processes are good, if your assumptions are good, if you're actually, in this case, manually probably isn't an option anymore. Like, if you have 10,000 servers, try deploying something manually to all of them. Like, you'll need weeks. But it doesn't matter how painful actually this is in deployment process, because again, when you do deployment process, it doesn't matter if it's 1 server or 100 servers, you actually control it. You know that you're doing it. So even if something goes wrong, you will be there. You can react. The fun starts actually when something goes wrong, because then real users are affected, people are annoyed or losing money or losing houses, who knows what, and then you need to solve the problem very fast. And in this case, you actually find out how your system is good, how your processes are good, because like deployment process is only one of them. Because you can say, okay, there is a problem, let's revert to the old version, right? Let's just do the rollback. Usually this helps, but sometimes it doesn't help. And again, if your rollback takes a few days, then it's not really good. So there are some important questions that you need to ask yourself during the whole process and all the time. You shouldn't ask them only at the beginning of the deployment process, actually development process. You need to ask them constantly and always keep it in the back of your head. And the first question is, will you know actually if something is actually broken or not? How do you know if something is broken or not? Do you have some monitoring tools, some dashboards, or alerting? No. Because if you don't know that something is broken, then how can you fix it, right? And again, like, I can't stress this enough, because I know that some actually companies were relying on social media to actually see people complaining about their product. And this isn't the place where you want to be. You need to know if something is broken right away, so you can react to it. This might look silly, right? Will you be able to fix it? You know, and how fast? Well, you built it, right? So you should be able to fix it. But again, like, if the process is very simple, if you have like very small number of users and maybe just 1 server and 1 database, or don't even have a database, then in all situations you will be able to do it. But if the systems start to grow, then a lot of things can go wrong. You need a lot of complexity. You have several firewalls, layers, networks, load balancers, servers, who knows what. So the chances are that you will not know everything about your whole system, that you will not be able to access all parts of the system, you will not be able to change all parts of the system. So it means that you need some other people help. But again, you need to know who those people are. And again, you need to know how much time you need to fix the problem, right? If you need like a few seconds, then you're good. If you need a few days or a few weeks, then you're in big trouble. Also, very important thing is if something really goes wrong, how important it is. What's the impact? If the impact is somebody goes to jail, then you should make sure that it doesn't break, right? If the impact is somebody's going to be annoyed for a little bit, then you can say, okay, like we can live with that, right? There are also some very important truths that you need to keep in your mind all the time. And the first is the question isn't if, but actually when your system will break. All systems will break. If there are users, especially large number of users, they will break. The only system that doesn't break is the system which doesn't work or doesn't have users at all. So also, systems will break in unexpected ways. And as you start going to a large scale, this becomes even more and more obvious, you know? Like when you have like small number of users, you can probably predict how they behave, but when you have like millions of users hitting your website, they will hit every single possibility, even the possibilities that you were not aware that they exist. Also, I know that some people really like tests, and they're like, oh yeah, test-driven development and BDD will solve all your problems. And for part of the story, they are true. The tests really help a lot. They add value to your code. They make sure that when you do some changes in your code, it's still good. It adds robustness, and it helps sleep better at night. But again, when users hit, and not a large number of users hit your system, then you will actually find out if your tests are really good or not. And you can probably, in most cases, you will find out that they're not really that good. So let's look at some deployment practices that they're out there in the wild. The first one I call poor man's solution, and you'll find out soon why. And I must say that I really love this solution, and I also hate it, because it can be extremely good, but it can be extremely bad. And it actually consists of doing everything, all the things manually. And again, I think that from my personal opinion, this is the best approach that you can have. Once you actually start doing the project, you want to do everything manually, because again, you want to double check, to see, to get the feedback, is everything as you think it is. But again, for this you need to do it manually. However, if you start to grow and you start getting higher traffic, then this isn't an option anymore. Because like doing manually, like I said, to 10,000 servers is not an option. So again, like what poor people would probably do, because of different reasons, either they don't know about the fancy tools, or don't have a time or a budget to actually learn them and buy them, they will start writing custom scripts. And again, this isn't a bad thing. This can be extremely good, but it can also be extremely bad. The good thing is that you're going to actually replicate what you're doing manually. So again, you already know it very good. Also, if there is some problem, you can just go into scripts and see what they need to do, and in a simple way understand, okay, what's the problem and how to fix it. But again, if your scripts are not really good, and if they don't handle errors very good, then you can end up in an extremely bad place. So, like I said, no fancy tools. There could be multiple reasons, right? For example, you can say, yeah, maybe we don't have money to buy them, or yeah, our people don't know about it. And again, like in order to use them, we need to retrain them, and again, that costs times and money. Also, one other thing is that, again, everything that you add to your system add complexity. Again, initial complexity and initial cost is always present. Doesn't matter how good technology it is. You only hope that over the time, the initial cost will be smaller than the benefit that you get in the long run. But with the poor man's solution, having good performance is not a trivial thing. You can achieve it, and I've been in companies that actually did this, and I was extremely amazed by the performance that they got. They could go into production every few minutes, and they were serving over 3 million customers all the time. So it can be done. But again, doing so is not an easy task. You need really people who know their job very good, who are skilled, who have very good knowledge in this, but also you need to give them time and to develop it in a good way. But of course, there's some obvious problems with poor man choice. And the first one can be like, yeah, we do it like big boys, right? We don't need tests or anything, we just go directly to production. Again, funnily enough, this can be both good and bad. If you have extremely skilled developers who know very good the system, and you have also custom scripts which are done in a very good way, this can be actually beneficial for you, because you can move extremely fast. And again, like I've been in companies that does this, and again, like initial thought was like, really? But then you see it works. But again, like if you don't have very skilled developers and you don't have very skilled engineers and the scripts are not good, then I would be worried if I was you. Also, very often there is a problem like it worked on my computer, right? Well, we all know that we don't ship our computer to the customer, so again, it's not an easy thing to do. Another very common, I would say, the pattern about the deployment process is called blue and green, and I think that most people are familiar with it. In a nutshell, it says, okay, you have some infrastructure, and you call it blue, right? This can be one server, it can be a multiple servers, it can be a full data center, but whatever it is, we just call it blue. Why we call it blue? Because we have exactly the same copy of it, and we call it green. So, like I said, exactly the same copy. So if a blue is one server, the green is one server. If blue is one data center with a million of nodes, then the green is also one data center with a million of nodes. They should be exact copy and mirror of one another to the smallest thing. If there is differences in blue and green, then the system will behave in a different way and you will have hell to find out what's going on. Of course, in this case, you need a load balancer and it needs to be able to talk to both blue and green. And how this works is actually that at any point of time, you only send your customers and users to one. So either it is blue or it's green. In this case, we say we go to the blue, right? So let's say this is our setup. We have blue and green. We have version 1 and blue. And then we are busy. We develop a new version and we want to ship it to our users, right? So what we do? We put it on green. We do all our tests, our integration tests, functional tests, performance tests, penetration tests, whatever. We think all is good, and then we do the switch. And we instantly switch everybody from the version 1 to the version 2. The obvious benefit of this, that it's instant. You can't beat this. So in any other setup, you need time to actually send users from the version 1 to the version 2. In this case, they will blink and they will be on the new version. So this is extremely good thing. But again, what happens in this case if something breaks, right? Well, if something breaks, we can then very simply just do the rollback and go back to the version 1 instantly. Again, speed in this case, moving from one version to another, is instant and extremely good. Again, one thing that if you go with this setup you need to think about is actually what happens if users are logged in. If the users are logged in, then you might think, okay, yeah, but what we do then with their sessions, right? Well, the good thing about the blue and green is that you can actually make this per product, per system. So you can actually take our sessions in a separate system, not have a sticky sessions, and then you have a blue and green for our sessions, and you have a blue and green for application which does the business logic. And in this case, if you do go from one to another, users will not lose their sessions. Again, at one point you'll probably need to move the sessions from the blue and green, and then it will not be that trivial. But again, it can happen. It can be done. So there are all good things for blue and green, right? But there is one huge problem with blue and green, and that is cost. Because like I said, we want blue and green to be exact replicas of one another, which means that at any point of time, half of our capacity, half of our infrastructure and resources are just staying still and doing nothing. And again, like if you're a startup, then you need to pay for 2 servers, and that can be costly, right? But imagine if you're at the size of Google or Facebook. How much you think that they need to have servers laying around, right? And like if you have double the size for that and half of it don't doing nothing, then it's extremely expensive and you're going to feel it on your budget, no matter what your size is, no matter what your budget is. Some companies actually go and try work around about this, and they say, okay, yeah, but we will use blue in the production, then we use green for the testing and development and whatever, and then when we want to do actually the rollout, then we use green as it was instead in this case. But if you do this, then if there is a problem, and again, the problem doesn't have to be right away. Problem can be few or 6 hours after you actually introduced it, because maybe you have some caches that start being invalidated. Then you lose this ability to instantly go back, to roll back. So again, cost here is a big factor, and it's a big downside. And again, I haven't seen, because of that, really a lot of usage of blue and green. Because again, like if you say to your business, okay, like we're going to buy this huge pile of servers and just put them on site and don't use them, they will say no. The other approach, which is also very often used, I don't know what's the name, so I called it modern. is you have, oh yeah, also, I forgot to say, mention in this case, blue and green have to be able to handle all the load at any time, so even your peaks, which means again, like if you like have irregular visitors, so for example during the noon, I would say they are like crazy, and during the night there is nobody, you can't scale up or down with this case. At every single point of time, you need to have exactly same capacity, and you have to have a capacity to serve all the load, which again isn't very good when you think about the cost. So that's why we come with a modern approach where you have like multiple nodes. Again, you have a load balancer, and the load balancer talks to all of them. And again, instantly good approach that you can see, the good thing about this one is if you need more capacity, you can just add more boxes. If you need less capacity, you just remove the boxes. So in this case, you can dynamically add or remove the capacity that you need, and also in this case influence the price that you're going to pay. So you're not locked in and having like huge amount of servers just in case there's like Christmas peak or something like that. Again, in this case, the version 1 is present on all the nodes, and at one point, again, because you were busy and you developed a lot of things, you want to put a new version. So what you do, you removed, for example, some of the nodes from the load balancer, they don't get the traffic anymore, you put version 2, and you put it back to the load balancer. Then you do it again for the next one, and you do this until all the nodes are the new version. Like I said, good thing we can add and remove infrastructure and capacity as we need. Again, the one thing that in this case we really have to worry about and we need to think about during our deployment process and also during our development process is that users will see both version 1 and version 2 at the same time. So everything needs to be able to handle that. And when I mean everything, I mean really everything, like from your session, from your load balancer, from your network, from your database, from your code, absolutely every single thing. Because in this case, switching from one version to another isn't an instant. It can take a lot of time. Even if it takes a few minutes, again, if you have a million of users hitting your website in just a few minutes, that's still a lot of users. Also, extremely funny thing in this case, what happens if we're in the middle of deployment and then we see problems on one node, right? Or maybe even two. Then rolling back is kind of more tricky, because then you're like in a situation when you're half done, half not done. And then like what do you do? Like, do you continue with upgrading to all nodes and then start reverting all of them, or just stopping the process in the middle and start rolling back the ones that you deployed, or do something again different? Again, in this case, your actually procedures and the systems and everything around it are going to be really tested, and also the people. So also your engineers and everybody around them have to know what to do in this case, because this isn't a trivial situation. And again, this will happen. Again, like I said, if we think about what the cost is going to be if something breaks, we said there are systems that if they break, people will lose houses, people will end up in jail. So in this case, usually people go with Canary Deployment, which means you have some setup of resources, we don't know how much and we don't really care, and we have users, and users can interact with all of them. So when we want to introduce some change into our system, because we're not sure that how it's going to go, we remove small chunk of it. Again, like this chunk really depends from use case to the use case, from your situation, from your company, from the number of users that you need to serve. You update only this small chunk, and then you send the traffic from your users to this chunk, but only small %. So only partially, and then you watch. And it's called Canary because of the mines, right? If in the mine Canary dies, you know that you need to run. So same idea here, right? If this dies, then it means the change that you just introduced was very, very bad. But again, luckily, in this case, you contained it. Actually, you are contained in a small part of the system, so not everybody is going to be annoyed. Again, for how long you're going to do this really depends. You can do these Canary deployments, and it can take like a few minutes, it can take a few days, it can even take a few weeks. You can even like say, okay, like we want to test some features and we think it's very bad, or maybe it can go very good, and then we want to actually have like some pilot group, and we even tell the people, okay, you're in the pilot group, so if it breaks, don't, we told you it can break. But again, the good idea behind this is once you're actually, so say like experiment group is done, then you actually, you know everything is good, you can set everything to for all your infrastructure. And now you know everything is good, nothing will break, right? Well, let's now talk actually about some tips and some insights that hopefully will help you. First of all, your deployment process needs to be easy and painless. Because let's face it, if it's not easy and if it's not painless, people will not do it. People will hate doing it. People will feel pain all the time. And again, you want your developers to actually do deployments, to actually be involved in them and to do them often and do them all the time. Because whenever you do it, you actually learn something about it. Because again, we all have some assumptions how we think that users will react, how they will do. But again, until you actually send it to production into real users, we don't really know. So if your system, actually your deployment process isn't easy and painless, then people will just avoid it. And that's not something that you want. Also, it needs to be fast. Again, I worked in companies which actually shipped software into the production once per year, maybe. I worked in companies which try to ship product actually like once a few weeks, once a few months, but I also worked in the companies which ship the product every few minutes. So if you're on that scale, and if your deployment process is very slow, then you're losing a lot of time. And again, think about what if something goes wrong. Then in that case, you need to do rollback, right? And again, like usually your rollback process is similar to deployment. So if it isn't fast, it means that you're losing a lot of money, you're losing trust from your clients, and who knows what. So it needs to be fast. The faster, the better, because you don't want also to spend a lot of time spending on it. Also, it should be one click or automatic, because again, like when you're on a small scale, you can probably deal with a lot of manual tasks. But again, if you do it too often, you're going to be bored very soon, and you're going to hate it. So the closer to one click it is or automatic, it's better. Again, depending from your maturity of your company, of your systems, of your engineers, maybe you want to keep it on one click because you want actually for some physical person to actually press the button, start the process and actually look if all is good or not. Maybe you don't want to automatically go with everything that you do directly to production. Maybe you can't even handle that. Because again, to go fully automatically, then you need to have a lot of tests and a lot of, so say, gateways that are actually checking the quality and if all is good or not before you hit the production. So again, you should be almost one click or automatic, preferably. Again, it needs to be often. The more often you deploy, the more often you get the feedback about your product. The more often you see how good or bad it is. You'll see more things which are wrong with your product or not. And then we come to actually one subject that if nothing else you remember from this talk, please remember this: monitoring. Monitoring is extremely good and extremely important thing, especially when you go to the high load of customers. When you're a small number of users, then you can probably handle everything and find out the bugs even a few days later, nobody will care. But as you start going on a larger scale, as your systems start becoming more and more complex, the chances are that you will not have overview of all the things that are happening. Like I said, like having a lot of tests and all those kind of things is a good thing, but it doesn't guarantee you the success. And if you have a monitoring, then you have your eyes open all the time about all the things that are happening at all the time. And again, you need monitoring, you need dashboards, you need automatic alerting, so if something goes bad, you need to find it right away. You don't want to actually read like a few days later on Facebook or on Twitter like your product sucks, right? And again, the better monitoring you have, the better it will be. And again, one thing that I learned in a painful way is it doesn't matter how good your monitoring is, when something goes wrong, then you will actually see that you still probably need more monitoring. Because if something happened, it happened in the past, and then you want to know actually what went wrong. And all the monitoring and data that you get from it will help you. Again, rollback. Usually, if something goes wrong, in most cases, the best solution is just roll back. And again, if you can do it instantly, that's even the best thing to do. Like I said, I worked in a company which deployed the product a few times, actually like every few minutes we went to production. And in this case, we had a huge amount of users. If something is bad, people would tend to do, oh yeah, I know what the problem is, I will fix it. But again, you can't be 100% sure that that's actually the case. You might think that you know what the problem is, but when you actually fix it and push new version, you can find out that something else is also broken. So that's why we said in this case, always roll back. always roll back, go back, because the previous version is more likely to be good one. Again, you don't know. What can happen is also that you roll back and you find out, oh no, the problem is still there. So maybe it was introduced in the previous version or the previous version. So again, you need to be able to do rollback, but not only to previous versions, but at any point of time in the past. And again, it needs to be instant, it needs to be fast, because as long as there is users who are seeing the problems, who are seeing, encountering the issues with your application, they're losing faith in your product and you're losing faith in you. And again, that will cost your money, that will cost your customers, that will cost your reputation, and that's something which is very difficult to gain back, especially if somebody ends up in jail because of that. Like I said, having tests is extremely good thing. Having tests is good because it helps you sleep better at night. It helps you when you do some changes in your code and actually see, okay, like instead of I think it's good, that it should be good. So writing tests isn't a bad thing. And again, like I said, I know some people are really religious about the TDD and all this kind of things. So I'm not really on that level, but yeah, I think that having tests is a good thing because also it helps you as a developer. But again, they're not really a replacement for real users. The real users are going to behave in a ways that you just can't predict. You know, if you have a big system, what can happen is you can think about maybe 100 things that can go wrong. And you say, okay, like, hey, I know these kind of things can go wrong, and I'll actually make some fail-safe and some kill switches and something and make sure that if any of those 100 things go wrong, my system will still behave in a good way. But yeah, but probably there's like 101 thing at least that can go wrong. And you probably didn't think about it. You know, sometimes, you know, even a hard drive can go down, the network can go down, you can lose the power in one data center, you know, like, have you thought about that? And again, like, sometimes people say, like, you know, when you actually see what users do, you say, like, wait, but they shouldn't be doing that, and that system shouldn't be talking, right? But again, like, you just don't know. So that's the fact that you need to accept. Again, automate as much as possible, because again, if you automate things, that it means that you can move faster, then you can actually solve the problems much faster, and then again, that you need to do less manual work, which means that you will probably enjoy your life more and you will be spending more time actually on doing things. Because again, like when I speak to people and when I look, you know, people usually like developing software and writing features. People don't really like deploying software and putting things to production. That's the boring part. So if you automate that, then it's great, right? Imagine the world like when you just, after each commit, it goes directly to production, automatically. It's perfect, right? Well, not always. I think that everybody knows that from where is this, right? So again, even if you automate everything and if you think that everything is perfect and everything is good, again, something will go wrong. Maybe in your process for automation. So again, you need to think about what then. You know, will you find out about it? What will you do it then? You know, what skill do you need in this situation to solve it? And again, one thing that you lose with automation is actually knowledge about your current processes. If you're doing manually, then it means that you know everything that goes into deployment and you know all the steps. So even if something breaks, you probably know how to fix it. If you automate everything and you if you're new in the company and you just know everything is automated, then if something breaks, you will have no clue what to fix or where to fix or how to fix. Again, systems will break in a way that you don't expect and you can't predict. So this is the fact of a life that we need to think about. That's why I said, like, always think. Will you know if something is broken? Will you have knowledge to actually to solve it, and what will be the impact? Because again, you may find out that different parts of the system have different impacts. Some parts of the system are crucial, while some parts of the system, if they break, you don't really care. So you need to have different quality gateways on the different levels, and you need to fail-safe them in a different way. If some part of the system is crucial, then you need to make sure that it will stand even after nuclear attack. Again, deployment is a feedback. So the more deployment you do, the more feedback you will get. And again, that's why you want everybody to do deployments, because then you will get real feedback about the things. But also it means that it needs to be easy, it needs to be fast, because you don't want to spend too much time on it. It needs to be instant. That's also like in Agile, right? We don't do a waterfall anymore. We do small iterations to get the feedback about the product and if is it good or not. There are a lot of tools out there. Kubernetes, Mesos, Marathon, Ansible, Chef, Salt, you know, Puppet, just to name few of them. There are really a huge number of them. And again, I would suggest look them up. Investigate. Are they good for you? Are they actually solving all your problems or not? For example, if we go back with the modern deployment that they show, actually Kubernetes does similar thing. The only difference is it asks you, okay, how much nodes do you need to have at a certain point of time? You say, for example, 10, and then you say, okay, how much nodes I can use during the deployment? And then you say 1. Then it actually doesn't remove the node from the load balancer, it adds additional node to the load balancer. So at any point of time, you always have 10 nodes. So again, there are a lot of tools out there that probably solve all the problems that you can encounter. But again, maybe they will, maybe they will not. Again, new technology means new complexity plus learning. So again, all the people will say with the new tools, it's perfect, it's going to solve all your problems, you will never have to do this thing again. But again, you will not know about the pain points, you will not know about the issues, you will not know about the corner cases. If you have some systems in place, the chances are that you already know all the good parts, but also you know all the bad parts. And if you actually contain the bad parts in a certain way, then maybe you don't really need the fancy tool. So always be critical. Look at the new things, look at the new tools and the new trends, but be critical. Really think, is this something that I really need? Well, is this something that will add the value? And again, you need time to learn it and to actually master them. Also, don't underestimate the poor man choice. Like I said, I've been in the huge companies which had enormous budgets, and because they said we are going to buy all the fancy tools in the world. And then they couldn't go to production for months and months and months. And I also been in companies which are said like, yeah, we're going to do it like old school, like all the scripts and things like that, and like with rsync actually. And they managed to go to production almost every second. So don't underestimate it. It can be extremely powerful, but again, it needs to be done in a good way. Again, one more thing is having development, test, staging, and production environment is a good thing. So if you have something like this, then automate everything is much easier, because you can just say, okay, like we do it on development. If its development is good enough, then we push it to the test. In the test, we have additional suite of things that we are going to do and check, and we think this one is good also, then we go to the staging, and if everything is perfect in staging, then yeah, we can go to production. But again, if you want to do it by a book, then it means that the staging needs to be exact copy of production. And again, you have a budget for that. It costs money. So if you can have it and if you can afford it, then perfect. If not, think some different way. Again, what you can do is maybe just for a critical part of a system, which is really needs to be rock solid, do it in this way. For other parts of the system, do it in a different way. There's also always the question, do we go bare metal or do we go via VM? And again, it depends. If you go with the bare metal, you get the best performance that's out there, right? Because you really get all the performance of the machines that you're using. There is nothing that you're going to lose. But again, then you need to think about all the things. Update software, update firmware, all those kind of things, making sure that everything works, and then you're all good, and then your hard drive dies. So again, there are downsides. If you go, and also, yeah, if you go with the bare metal, if you just want to increase your capacity with adding more machines, then it means probably ordering them, waiting for a supplier to give them, put them in some data center, connecting all the cables, installing all what you need to install, so it takes time. With virtual machines, you get the speed, you get the flexibility of all those things, and a lot of things you can actually just forget about it, and also if, for example, one application behaves in a bad way, you can contain it in its virtual machine, but again, you lose part of performance. You don't get as good performance as you can with the bare metal. So again, it depends. And the last but not the least is the databases. And again, this is a huge topic, so that's why this even like a talk in itself. Because again, when you're on a small system and simple system, making changes to your databases and making changes to your code is a very simple thing. But once you hit a huge size, it means a lot of servers, a lot of databases, and a lot of other things. And then actually going from one version of software to another, and also making changes to the databases and the tables and schemas and things like that can be extremely difficult thing to do. And it can take a lot of time and a lot of effort. Again, it's all about the mindset. Because if you have like a very simple, small situation and you have small number of users, then you can just delete some table, delete some columns, and nobody cares, right? Because you just push the code which is good. If something isn't wrong, then you just try and fix the code while people are complaining, but again, there are not a lot of users. Well, this isn't something that you can do if you have a massive amount of users. If you have a million of users hitting your application all the time, then you really can't play with like this. And also, one thing which makes life much more difficult is that all the changes that you do on the database are not really easy to do the rollback. You know, if there's a transaction which went wrong, then you need to go and fix them. If you delete some column or delete some table, and your code still depends on it, it's not like you can just very easily click the switch and the databases are there and all the data is there. Hopefully you will have backups, but again, it's a process which takes a lot of time. So how do you actually approach this problem? Well, usually what you do is, again, depending on the change that you need to do with the database, you need to write the code again, which works with the old schemas and with the new schemas. And again, if you're, for example, only adding the column, then you can just change the database, make sure everything is still working. After some time, push your new version of the code, which expects to have the new field, and then everything is perfect, right? Well, if you're removing the fields and things like that, then it's a little bit more tricky. Because first, you need to actually ship the code which doesn't use that part of the database that you want to delete. But again, you still need to update it. You still need to make sure that if there's some changes in the system, they go into database. Because again, if something goes wrong, you need to go back and to do the rollback to the previous version, so it still needs to work. Then after you're sure that everything works, then you change the database. Still fingers crossed, look for some time, make sure like days, weeks, months, depending how much users you have, that everything is good. And then if again everything is good, then you also could just continue, right? So again, this can be done, but it's a tricky thing to do. And again, in this case, you are going to lose your ability to really roll back for at any point of time. Because if you're just making changes in the code, you can at any point of time go back to history. But when you do the database changes, then you're losing that ability. So that's why you need to approach them extremely carefully and to make sure that nothing breaks. So that's it. Any questions? Yeah.
The risk of the load balancer. Oh, thank you. So in case, what if the load balancer goes down? What's your approach to that? Because that's a single point of failure right there. And the second question, if I may, I think that it's very easy to scale performance for, like you can, if you're using AWS or Azure or anything, you can just throw a bunch of new instances and problem solve for computation. But the biggest problem in scaling up is how do you scale the databases? That's my second question. Thank you.
Well, yeah, so the first question, what happens if the load balancer goes down? Well, then you're in big problem. Because again, like I said, that's your critical part of the system, right? So again, in that case, when you do any changes in the load balancer, you need to be very careful. And again, you can approach this problem either making sure that it never goes down or actually have a backup and actually just have multiple load balancers. So in that case, you can again mitigate it in some way. And it's not always the perfect solution, but like I said, you know, it's really depends from the system. And with the load balancer, I know that some companies do, they put, like, for example, Akamai or some other CDN providers in front of it, and then they have, again, the full data center, which is, again, completely ready for everything, and if something goes wrong with the load balancer in one data center, that they just say on some DNS level or something like that, just go to a different data center. It's extremely expensive approach, but it can solve the problem. So, again, like, depending on how critical your system is, you need to think about different solutions, and some solutions can be extremely drastic and very costly, but very effective. So again, it comes back how fast you can recover. You know, if again, like how many instances actually the load balancer is handling. Like, is it like a single instance or is it multiple instances? Because if you have like pool of machines which are actually dealing with all the load balancing, then you can lose a few of them and still serve your content to your users. Or you can maybe just say, okay, like, half of the nodes that need to do the load balancing went down, so then in that case we need to start rejecting the requests from the users and just say, okay, like, we're down, so at least half the people will see your product. So it's very difficult. For the second question about actually, scaling applications, it's usually much easier than scaling the databases. So yeah, that's why I said like that the talk about the database itself is the whole talk in itself, because again, if you go with back, I would say maybe 20 years ago, usually the logic was put everything in a database, put store procedures and everything in a database, because the database is very big, very strong, and then you can optimize with the store procedures and actually make it perform very good and make your application extremely stupid, so to say. Just calls to get the data and send it back to the users. Well, usually what happens is in the big systems, especially when you go really high scale, that's counterproductive. So in this case, you want to actually keep the database as stupid as possible, extremely stupid. So even like removing the foreign keys in a database, you don't want to use that actually. Although it's like against all the things that we probably learn in school, and we say, okay, the data needs to be normalized, it needs to have foreign keys, so all the kind of things. When you start hitting the high load, usually it turns out that it should be other way around, that the data should be denormalized, and you should have foreign keys, because in that case, you can much easier and faster actually replicate the data. And again, like you can have one database per table, and then in that case, it's much easier to actually add new nodes and actually scale it up. Because again, like if you have only one database and you have like million of tables in there, and you need to put another database with a million of tables, copying all the data, making sure that all the foreign keys and all relations work, still it's difficult. But if you have like one database per one table, then it's very easy. You need another table, yeah, you just put another one. You need to scale it up, you just add another slave. So again, in this case, you want to keep database as stupid as possible and keep all the logic in application. Because again, putting, like you said, putting new application is usually much faster than putting the databases. That's one of the things that actually I learned in booking.com, because to put a new server and put all the code there and working, from application point of view, we need maybe half an hour max, maybe even less. For database, we need at least 1 day. And it's actually like why you want to keep a like database as stupid as possible. Okay, any more questions? Yeah. Can you just wait for my...
The question is about rolling back and
Okay.
obviously forward after we fix something. So in a live system like booking.com, if we just stop and we do our upgrades on the database and so on, there is new data coming in. So we need to be synchronized somehow with the new thing. And then if there is something wrong, we have to roll back. With the execution code, this is easy. You just reload your jar files and okay. But the data, does it mean that for every table I need to have a snapshot that is synchronized with the incoming data in the new version, the old version, and the previous one, so that I can do rollbacks any steps back?
Well, again, So again, it really depends from your actual database, and again, that's why I said like the database itself is extremely painful part, because like I agree with you 100%. If there's something wrong with the code, then you just put the old version of code, and that's it. That's the problem. But if the wrong data goes into your database, then depends again. Like that's why I asked how important it is. What's the impact? If impact is somebody is just annoyed, then you can just ignore the data and just delete it, or even leave it there forever. If it's something people are losing money, then you need to know exactly what happened, and then to investigate and actually see, okay, like how we can approach this, how we can solve this problem. So yeah, I was also involved in actually some situation where we thought everything is good, everything is perfect, and then it turned out that 1.3 million was missing, you know. So it took us about a month to fix all the problems. In the end, we fixed the problem, but again, in this case, also that's why I said the monitoring is extremely important. The more monitoring you have, the more logging you have, the more information you have, it's easier for you to actually figure out actually what went wrong. And then you can actually figure out how to solve it and how actually go back and simply one step at a time just fix the problem. But again, if you see something is going wrong, and again, wrong data is being written in the database, that's why you need rollback instantly. Because the more you wait, the more problems you have for the future. So it's going to be more and more problematic. Any more questions? Okay, in that case, oops. Thank you.